We get the next participants in the floor. When we talk about, I completely agree with Maria that autonomy is not real at all in a world so complex and with so many players. Now, sovereignty, we need it, but who is going to pay for it, right? Are we willing to pay 2.4 times the price of the chips because we do them in the West? I mean, I think this question needs to be somehow answered. Who's going to push for it? Are we going to ask governments to subsidize? Are we, and how? I mean, I don't understand how we're going to do this, honestly.
Did you want to respond? Maria, I think
anyone has any idea there?
Anybody has an idea?
Just one clarification. TSMC charges the same price independently on where the chip is the wafer is manufactured. So in somehow this is absorbed at a worldwide level.
Maybe you can say something, because I actually had the pleasure to work with Maria on this project to build ESMC in Europe. And actually, it was a fantastic journey. It was not an easy journey. But in the end, I'm very proud what you accomplished, because actually with that, I think it is one of the important anchors to put Europe again back on the map for advanced manufacturing. And I think this first step can be followed by a second step. We also had a lot of discussions about cost. And, and Maria and I agree about many things, but I didn't agree with Maria about the cost. So I still feel there's opportunities to bring the cost down, and also to understand, what is driving this cost. Is the cost coming because we are using chemicals from Taiwan? Can we redevelop, let's say, the chemical industry in Europe? We spoke about, particularly Ajit, about the ecosystem. I think it's very important to redevelop the ecosystem, and the rest will come. So I definitely believe that at the moment the cost of manufacturing in Europe is higher than manufacturing in Taiwan. But I also believe there are good reasons why, and also believe that a part of those reasons, to my opinion, can be addressed. And it's just a matter of rolling up your sleeves and working hard.
Rolling up your sleeves and working hard. Rutger, now take us into this world of hybrid and electronic vehicles and how they're changing demand for semiconductors.
Well, I think, it's actually fascinating what's happening in the automotive industry, right? I still remember when I was a young engineer, we spoke about semiconductors are going into automotive, and maybe there will be a semiconductor bill of $100 or $200. Today, as we speak, the average car in the world has $950 of semiconductor content. And it's also fascinating to see that actually the cars with the highest content are at this moment built in China, where the average is about $1,150. And I expect in the next few years, and it was also indicated by Ajit, but the strong growth in automotive semiconductors, that it will no longer be around 1,000, but will go to 2,000. And it means that there's a lot of change happening in automotive. But it's not the number of cars. If you look at the car manufacturing, it's about 90 million pieces a year. And if it has a good year, it's 5% higher. If it's a bad year, it's 5% less. So it's not the number of cars, but actually it's the content of the car. And the electrification of cars is driving a lot of change, not only in the car itself, but also in applications. Let me say a few words about that. So one of the changes that we see at the moment is that if you look at the car, a lot of the content in semiconductors has been coming from silicon. And silicon is still the major horse. I would say 85, 90% of the content is still silicon. But if you look now that a material silicon carbide is coming in, and in the next few years, actually silicon carbide will start taking parts of the silicon business, or at least of the growth of the silicon business. And then another material actually that will be coming up in, I would say, 3 to 5 years is gallium nitride. And why those different materials? Because actually those materials have different, I would say, qualities. And silicon is well understood, and it's also highly available and it's very cost effective. If you go to silicon carbide, you have an ability to move to much higher density of power, and that actually helps the silicon carbide material itself. And then if you go to gallium nitride, you can work with different frequencies, which is another phase. So I believe that the change is going to happen in the next few years. But after that, I think we may see other materials coming in this domain, which have to do with gallium oxide, or it has to do with diamond. There are different materials that actually are even more efficient or more capable in these areas of applications. Apart from the materials, I would say there's also a lot of innovation going on in assembly. If you look at the modules that are being used in electrification of cars, you know, it's getting highly advanced. It's not just semiconductor chips that driving power, but actually it's sensors, it's microcontrollers. And the challenge, of course, in those complex components is that you have to deal with high currents and high voltages. And that means also there's a lot of requirements that have to do with safety and reliability. One of the interesting parts is that there is maybe a little bit technical, but there's one thing happening, you know, every time we increase the power in the device, we try to make the device smaller, but also with more power. And then there is a parameter which is called a short circuit behavior of the device must still hold. What does it mean? That if there is a malfunction in the car, if the engine is actually having a failure, then the semiconductors need to protect the rest of the car that is not burning out. So this whole short circuit behavior becomes more and more complex. And that requires other materials. Maybe one day it requires diamond as a solution in order to deal with that. Not only, let's say, in let's say materials there, but also in sensors. And then, you know, I think also my colleague will speak more about that, you know, we will see different voltages in cars. You know, we're moving now in applications to 48 volts for the simple battery, but then we move to 400 volt, 800 volt, even 1200 volt. And then I think some of the previous speakers already said, you know, because of that there are changes not only needed in the car, but also in the infrastructure. Who is going to supply the power of the charging stations? And there, you know, again, new semiconductors are happening with solid-state circuit breakers, but also solid-state transformers. So this whole electrification of cars is driving a lot of semiconductor content, but also a lot of semiconductor content in applications, and also later on in services and business models. I think it's fascinating what's happening at the moment.
So Miguel, pick up on that. How do you see the key electronic systems within the car evolving?
Wow.
Big question. I guess so.
Yeah, it's a big question. The right answer or the fast answer is the components are evolving really fast at this point in time. And fast is a very relative term at the end of the day. For example, if you ask a professional athlete to run 100 meters in 10 seconds, he will tell you that this is slow, but if you ask me to run 100 meters in 12 seconds, I will say that this is extremely fast or almost impossible. And so we have to think that we are in a, I would say, more than an evolution, a revolution of what a car means these days. I mean, we are changing, or it's changing our perception of what a car needs to do, or what it has, or what it's doing. And I think it is important to have that understanding of the existing situation in order to understand how much electronics are changing. So if we think about what a car is, in the direction that the car electronics are going to, we are going to kind of a software-defined car at this point in time, where all the electronics are having a big impact on the behavioral of the mechanical aspect of the car, as well as how the customer or the driver uses the car. And we are becoming, the car is becoming kind of a mobile phone on wheels, right? And that as well helps in the four pillars of the automotive development, basically, which is the electrification, the autonomous driving, the communications, and as well the how you configure the car in order for your own preferences. So if you consider that as well, that has an impact on how the people understand the usage of the car. And at this point in time, they will start using the car as part of their, let's say, digital environment. They will be using the car as they were using their mobile phone, where they will be able to update the performance of the car, or they will be able to interact with the car as another communication device. And at the same time, they will have the feeling that to some degree, they can always own a new car because you change some of these features. Apart from the user experience, I think it's important to highlight one other complexity here, and is how to develop these systems. What we can see at this point in time is that we see a big interaction. How can we develop such a complex cars? And at this point in time, we have to think how they are made nowadays. And what it happens is that there are local control units. You can find hundreds of local control units for particular functions. And the way we are progressing is towards reducing the numbers of ECUs or control units in order to have localized ECUs with higher processing power, which will enable us to simplify the hardware to software interface. And the other aspect that is important in order to enable these complex circuits or complex cars will be to find this complex partition, or to define the partition between the hardware and software that will enable the hardware engineers to work properly and to find the most efficient solution.
So I have a question for both of you, and that's about, is there a place where Europe can really define itself in terms of leadership in the electronic components of cars going ahead?
You want to go, Miguel? Huh?
I think what Bosch historically has been proven is, it's a reliable component manufacturer for automotive. And it has been like that over the last 100 years. And I hope it will be the same over the next 100 years. So there is a big effort from all the engineering and management team in order to guarantee that we are always one step above what the market needs in order to define or to work on the automotive solutions that the people need.
So let me build on that, what Miguel said. So definitely Europe has a very strong position in automotive. You know, if you look at Infineon is the biggest automotive supplier, semiconductor supplier in the world, also in China. Look at NXP, look at ST. The European companies also have a very strong position in industry. So that means, let's say, in analog, in sensors, in automotive. If I speak about Edge AI, I think Europe has very strong competences. I think for that reason, Europe certainly can take up this fight. But Europe also has to change. You know, it's no secret today that my company actually, most of the innovation is taking place no longer in Europe, it's taking place in China. So that means that as Europe, we need to change. I think we do have the capabilities, we do have the competencies, but we need to change. And Ajit spoke about wake up. I think it's definitely that it's not enough in today's world to have the competencies, but you also need to put the energy on the ground and actually you need to move forward. So I would like to encourage my co-citizens in Europe, you know, to be less worried about topics like work-life balance, but really roll up the sleeves, work hard, and rebuild Europe. And I think we can do that. But it's also, I think, a mental change that needs to happen. But with that, I'm confident, let's say, with the capabilities of the talents, with the people we have, we can be one of the leaders in this industry.
Yeah, I know I have a question here, and then we probably have time for one or two around the room.
So how do you answer the topical question that Europe decided to put a computer on a car, and China moved to put wheels on computers, right? Which is a completely different approach, and that is somehow one of the, topical explanations of why the automotive industry in Europe is losing ground versus competitors in China.
I think there's one more step that's even more important one. I think that actually, if you look at the electrical car, it's completely different from a combustible car. Combustible car is extremely complex. If you look, let's say, at an electrical car, the whole assembly is much simpler. Different electronics, different systems, and you have to think more in the services and applications and business models. I think we in Europe, we still are a little bit in our traditional interaction between OEMs and in working with the tier 1s and tier 2s. While in China, you have companies working with a new concept. You know, they don't build the car anymore. They just have a contract manufacturer building the car. They make the design. So I think in Europe, we have to get a little bit away from our strengths. That was the original setup of the supply chain and value chain within automotive. And I think we have to get more into the new models and simply try out and enjoy also the uncertainty. And then definitely I believe that we have the talent to win back clarity that is our birthright, I would say.
Alejandro. Daniel.
Yes, one first one is, I'm not very much believing in birthrights. I think that you win that with time and sometimes you lose it and then you need to fight it again to get it again back with you. Within automotive and semiconductors, the number of chips within a car has moved from scores a few decade and a half ago into hundreds now. Many of those in the past were with a clear supply chain following the just-in-time model that the auto industry has been following for the last 2 decades plus. That's not anymore as easy as before. Nexperia just a few weeks ago caught all the industry offside, let's say it like that. Most of the leadership on the automotive industry needed to stop all the meetings and calls that they had just to come in to try to solve that problem. Do you see or foresee any kind of change or move from or adapt from that just-in-time model, which was secure with the supply chain before, into something which is a little bit more reliable to provide the products to the customer, to the market? Or do you think that we're going to continue as is and just hope for the best? That's one question, sorry. The next question is,
We should keep it short because I know we have
yes,
one more coming.
do you foresee a consolidation in the industry in Europe, in auto car makers?
So first of all, first question. My experience from the last 20, 30 years in automotive semiconductors is that the automotive industry has a very short memory. Every time when something happens, then they say, we're now going to do different. We do realize that the just-in-time model has not worked for us anymore. But at the moment that there is financial pressures, it seems to be that the automotive industry tends to go back to its old behaviors. And I think, the pressures during COVID were, I think, worse than I have ever seen before. But nevertheless, you see a little bit of the tendency that the automotive business at this moment is, I would say, okay. It's not growing strongly at the moment, but you see again that there is pressure on the OEMs. They put pressure on the tier ones. And the whole business model again is under pressure. So I hope that actually we learned a lesson, but I'm not sure that everyone has learned a lesson. Nevertheless, I think, I would only say that rebuilding this ecosystem in Europe and not just focusing on one aspect of building a car, but also multiple aspects, to my opinion, is the answer to the question. So I think we definitely need to become broader, not just focus on one component, because like you mentioned, there are many components that are critical. Xperia is the best example. Those are very simple parts, but if they are not delivered from China, you can have all the advanced chips from NVIDIA and other companies, or the microcontrollers from Infineon, but you cannot build a car. And it shows that building a car needs actually a very successful and well thought through supply chain. Yeah.
I'm going to take one quick question from Heike, and then Marcy's going to come up and talk about coffee. So what's happening during coffee break?
So I will be fast. So I have just a follow-up question on Juan's question, and I want to dive a bit deeper in. I mean, we discussed a lot about how to improve and how to strengthen Europe. And is it talent? Is it resources? Is it our risk-taking capability? Is it the government? Is it the public funding? Is it the government funding? Is it labor laws? How do we improve it? How do we kind of come out of the bottom and increase? But I think we need some fundamental changes. And that's I miss a bit in the discussion.
Okay. I think the aspects at this point in time that I would not say we are at the bottom. I tend to take a look at sometimes at the positive side of things. I think that we have to focus on our strong points. And I think our strong points at this point in time are very clear. I mean, we have good talent pools. We have good system knowledge. We have OEMs and tier ones that can work together in order to find proper solutions. And apart from that, we can develop, let's say, alternative silicon technologies or alternative technologies that will enable us to define better products. One example is silicon carbide. Basically, that will enable us to progress in our new products and offer more competitive aspects. For example, the talent, it has always been an issue, and I believe that a lot of people is aware of that. A lot of people is working actively in that topic, and I really think that the talent of the European engineers is very high, and we can count on that in order to make us progress and to find.
I'm not questioning this one.
That's good.
And